Okay, in this video we will talk about cooling technique, and we will refer especially to air conditioning heat pump. And here you see the symbols, the symbol for air conditioning, ice rods, and the sun for the heating pump. First of all, I will explain how it works, and to do it simple, I will look at the back side of a fridge. It would look pretty much like this. If you look on the back side of the fridge, you will see a cylinder in the bottom. That's the compressor. It has a motor on top and a compressor underneath. And you have some small tiny piping that goes up on the back side, back wall of the fridge, outside of it. That's the condenser. It comes back here, go to a pressure reduction valve, and it will go inside. And if you open the door on the fridge, you will see a metal back wall. That will be the boiler. And after the boiler, it goes back to the compressor, and it circles around. So you can say it basically contains some four items: the compressor, the condenser, the pressure reduction valve, and the boiler. In the fridge, everything is in one unit, so you just plug it in, and there you go. When you come to an air conditioning, it's a bit different. In an air conditioning, it comes in two or more parts, where you have the outdoor unit, where you have the compressor, and you have the indoor unit. The difference between an air conditioning and a heat pump is that you can choose where the gas go, because it has one cold side and one hot side. For example, when the gas comes out of the compressor, it will be approximately 20 degrees Celsius, and it will be a gas. And the thing is that in the system you have a liquid, a cooling gas, that has a boiling point below zero. Normally on an air conditioning unit, the boiling point of the cooling gas is around minus 25 degrees Celsius. So here they come out of the compressor. We used to call it a cooling compressor or a freezing compressor. It's a misleading name because no compressor have ever produced frost. They can only produce heat. And another thing is that there is a direct connection between the pressure of the gas and the temperature. So it comes out here as a gas at 60 degrees. It goes through the condenser, and if you use the indoor unit as a condenser, then you use it as a heating pump, because it will give off heat indoor and heat up your house. So when it comes out on the other side, it will be around 40 degrees. So it have lost 20 degrees of the temperature which have been used to heat up your house. But there is a difference also. It goes in here as a gas, it comes out in the other end as a liquid. And here it comes to the pressure reduction valve. You remember what I said, that it is a direct connection between the pressure of the gas and the temperature. Well, when you reduce the pressure, you also reduce the temperature. So you have a sensor between this valve and the compressor that regulates how much it should open and how much it should close. In an air conditioning unit, when it comes out on the other side, it will be approximately 0 degrees Celsius. And it's still liquid. And then it comes into the boiler. And when it boils, it goes over to steam. And if you use this cold liquid on the indoor unit, then you say you have an air conditioning. So it goes here and boils and comes back in here as steam, and it compressed once again, and so it goes around. That's basically how the system works. System installed before 2000, 2002, and if you look at the label on the outdoor unit, you may see R22. That is freon gas. That is not allowed any longer. The reason for this is if you think that you have the globe, the Earth here, and around here you have the ozone layer. Freon gas contains chlorine components that would deteriorate the ozone layer. And what does it mean? Well, ozone layer is kind of like the globe's sunglasses. It's kind of like a filter that reduces the ultraviolet radiation from the sun. Ultraviolet radiation from the sun can be bad for your eyes. It can increase skin cancer, and it can give you a number of problems that you really don't want to have. Was promoted to come up with ideas. They come up with a number of gases, and the most used gas today is this one here, R410A. It is not bad for the ozone layer, but this one shows how difficult it could be to be environmental friendly, because this gas contains carbon dioxide, known as CO2. And what does that mean? That means that if you think that you still have the globe here, and here you have the atmosphere, and this carbon dioxide will stay within the atmosphere, and that will prevent or reduce the heat from the planet to escape out in space. So it will kind of, the heat will reflect. It comes to the atmosphere and it will reflect back. And then you have the phenomenon which is known as global warming. What they did was they come up with some rules and regulations. And the idea is that those who are working with these cooling gases should not let anything out. And also mean that technicians who is working with them should be qualified. Meaning that every installer should have a certificate like this, showing that the person who do the job, installing it, have the authorization of doing it. First of all, the firm he works for should be an authorized installation firm, but secondly, the man who do the installation itself should have a personally certificate. It's like a bus company. I mean, a bus company has a transport license for transporting passengers, but still the driver would need a driver's license. If you look at Benidorm, which is a very good example, because the reason why I'm doing it, because I know for a fact that a lot of technicians, when they come to rig down an old system, they just let the gas out in the air, and there it goes. I'm thinking, well, it's not important, it's only 1 kilo of gas. I mean, what difference does it make? I think this should maybe make you think twice. The thing is that nobody has so much cooling gas than private homes. If you look at Benidorm, there is approximately 80,000 people living permanently in Benidorm. We look away from the tourists and people who live there seasonally. Around 80,000. If you then estimate, which this is a number I don't know, but let us estimate that these 80,000 people occupied 25,000 houses, apartments or flats where they live. And let us say that every house, in average, have 2 air conditioning units. And every unit has around 1 kilo for cooling gas. Well, that means Only in Benidorm there are 50,000 kilo or 50 metric tons of cooling gas in private homes. There is no industry in Benidorm who comes near that figure. Nobody. And that's why, if you want to be environmental friendly, you should think about it. You can come up with a COP, coefficients of performance. The higher that number is, the better it is. For example, if this, let us say that this equals 4, that means if the unit consumes 1 kilowatt of electric power, it will give you 4 kilowatt of energy. Meaning you pay for 1 kilowatt and you have 3 kilowatts free of charge. But it is like the cost value as when you buy a car. If you buy a car, you will see in the specification of the car, you will see the consumption, how much fuel it will use per mile, per kilometer, whatever. And when you start driving the car, you will have a hard time to get the consumption down to the level that the manufacturer have written in the specification. And that can be the same thing here. But then again, it comes back to the installation. I know for a fact that the number of call themselves technicians who install this unit, they don't have vacuum pumps. They just open up, because when you buy the unit, the gas is in the outdoor unit, and you connect the pipes and you open the gas and flush it in, and you have an air bubble circling around in the system. It makes two things happen. First of all, it can make the system noisy. But secondly, is this value goes down. You wouldn't notice it inside, because you will have the same temperature, because the inverter technology that regulates the capacity of the compressor will compensate for it. But what it means that it uses more electricity to get the temperature you want to have inside than it should have used. So the money that you do believe that you saved by having it installed by a non-qualified person, you will lose it big time on your electricity bill. To use a vacuum pump to have the moisture out of the system before you let the gas in is very, very important. And the moisture and air comes together. If you can take out the air, you have vacuum, the moisture is also gone. It is important because the compressor, as I showed you earlier, is like a cylinder, where the motor on the top and the compressor underneath, but everything sealed up in one unit. When the motor is open inside and the cooling gas cool off the engine and go through the copper wire, the windings, which is only protected by a lacquer. So if the cooling gas goes sour, which it can do theoretically if you have moisture in the cooling gas, it will deteriorate the lacquer and the engine will burn up. And that will, of course, means that the system will stop. It doesn't work any longer. It is not easy to be environmental friendly and know what to do the right thing. But sometimes some things are simple. And for example, when it comes to air conditioning installation, you should ask for the certificate to the technician who do the job. If he is British, I think it will call F-gas certificate. And if it's Spanish, it will look like this one shown on the screen. It doesn't guarantee that the job will be properly and well done, but it guarantees that the person who do it, he's authorized, he's qualified, and he had a permit to do it. In 2014, the Spanish authority estimated that 80% of those who offered air conditioning installations did not have the permit to do so. So it's easy. Ask for a certificate. And if you don't have it, don't accept him to install your air conditioner.